Welcome to this session on test case design fundamentals, a core skill for every software tester. Test cases are the building blocks of any test execution phase. Writing well-structured, effective test cases ensures accurate validation of software behavior and helps uncover defects early. Let's begin with the basics. A test case is a set of actions executed to verify a particular feature or functionality of the application. Each test case includes a test objective, test steps, input data, expected results, and actual results. Good test cases are clear, concise, and repeatable. The foundation of a good test case is a solid understanding of the requirements. Review functional, non-functional, and user stories carefully. Each requirement should be translated into one or more test cases. This is where traceability comes into play, ensuring that every requirement is tested. There are a few key principles to follow when designing test cases. 1. Clarity. Write test cases that are easy to understand even for someone who didn't write them. 2. Reusability. Design tests that can be reused across different modules or versions. 3. Independence. Make each test case self-contained. It should not depend on the results of another test. 4. Traceability. Link each test case to specific requirements to maintain coverage. 5. Maintainability. Keep test cases simple and easy to update when features change. Now let's explore some key test case design techniques. 1. Equivalence partitioning. This technique divides input data into valid and invalid partitions. You select one representative value from each partition. For example, if an age input accepts values from 18 to 60, you'd test values like 25, valid, and 65, invalid. 2. Boundary value analysis. Here you test values at the edge of input ranges. Using the same age example, you test 17, 18, 60, and 61. Boundary values often reveal edge case defects. 3. Decision table testing. This method is used when the output depends on different combinations of inputs or conditions. It helps identify test cases for every possible rule. 4. State transition testing. Ideal for systems where outputs depend on current states. For example, login attempts might lead to different states like locked or unlocked. This technique ensures all transitions are tested. 5. Use case testing. Focuses on user scenarios and flows. This helps design end-to-end test cases that reflect real-world usage. Test cases can be written manually or generated using tools. When automating, ensure your scripts reflect the same clarity and logic as manual cases. Include both positive tests, where the system behaves as expected, and negative tests, where it gracefully handles invalid inputs or errors. Test data plays a crucial role. Design your test data to reflect all scenarios, including edge cases and exceptions. Consider anonymized or synthetic data to ensure compliance and repeatability. Lastly, always review your test cases. Peer reviews help catch gaps, improve clarity, and align coverage with project goals. In summary, designing effective test cases is about more than just checking boxes. It's about thoughtful validation that ensures quality software. Use proven techniques, align with requirements, and always strive for clarity and coverage. Next, we'll dive into specific test design strategies like equivalence partitioning and boundary value analysis in more detail. Let's keep sharpening your testing skills.